Good afternoon. This is Mike Brakey, and this is Black Swan Climate Theory, the cover up, part 4 of 5. In part 1, I gave you a brief biography of myself in the energy field for the last 40 years and why I have certain concerns about corrupted heating degree data. In part 2, I explained what heating degree data is, cooling degree data, total heating degree data, and the importance in historically seeing trends based on good, solid, raw data. In part 3, we talked about the Lake Lodge and the fact that we've reviewed the history going back to 1883 going forward, and that quite a bit of it looked like global warming, but in recent years the trends has been downward, and we're trying to decide for the lodge if we have global warming we could pursue a much smaller heating system as opposed to if we're heading towards global cooling we would have to go with a larger heating system. So with that in mind and that quick synopsis of the first 3 sections, we'll proceed with part 4, which deals with what is influencing the temperatures off the coast of Maine. Now we mentioned in part 3 that there was a theory I came across that might explain why there was a huge drop in temperatures 1904, 1905, and then a rise in 1925-26. And so, but before we present that theory, we want to talk about what is the definition of a theory. Keep in mind that as I point out this theory about local Maine temperatures, uh, it was something I came across in my scientific investigation. It's not something that I theorized myself. And it's up to each of you if you want to weigh the evidence and conclude if the theory is feasible or flawed. The the scientist who explains what a theory is Manhattan Project scientist and college professor Dr. Richard Feynman. These are the rules he's given in the 60s and which we should continue to adhere today. And here's what Dr. Feynman had to say.
Situation. Now I'm going to discuss how we would look for a new law. In general, we look for a new law by the following process. First, we guess it. Then we well, don't laugh, that's really true. Then we compute the consequences of the guess to see what, if this is right, if this law that we guessed is right, we see what it would imply, and then we compare those computation results to nature, or we say compare to experiment or experience, compare it directly with observation to see if it works. If it disagrees with experiment, it's wrong. In that simple statement is the key to science. It doesn't make a difference how beautiful your guess is. It doesn't make a difference how smart you are who made the guess or what his name is. If it disagrees with experiment, it's wrong. That's all there is to it.
And that definition of theory continues today. And I also liked one quote Richard Feynman has been noted for in the past, and it's up here. It says, "I would rather have questions that can't be answered than answers which cannot be questioned." So we'll keep all this in mind as we proceed. Now the theory relates to the fact that oceans store and transport heat. And we have the Atlantic Ocean right off of our coast. The working theory recognizes that the Atlantic Ocean current off Maine has a 70-year warming and cooling cycle that significantly impacts Maine weather. There is also a secondary influence from a 50-year Pacific Ocean cooling and warming cycle, which is delivered to us via the jet stream. And so if we look at this graph here, another thing I want to bring your attention to is that when we look at Earth's temperature versus the warming and cooling periods of the Atlantic Ocean, the Pacific Decadum Oscillatum and the Atlantic Oscillatum, we see that there is a 85% correlation between the two, which means they do influence each other. Remember earlier I mentioned we're always looking for a correlation that's over 70%. So I'm going to take the historical graph we showed in part 3, I'm going to stretch it out, and I'm going to put in these 50-year time periods. Then I'm going to lay out the Atlantic cycle, and I'm going to lay out the Pacific cycle, which is about a 50-year cycle. And at that point in time, we notice something. If we look at up here where I mentioned 1904, 1905, where there was a significant dip here. If we look down below, we see the Atlantic turn from warm to cold, and the Pacific with El Niñas and El Niñas, they're dipping back and forth, but it went into a slight cool period here. And that appears to have significantly impacted the huge drop in temperature we saw here. Now, if that's the case, when we come over here and see it swing the other way in 1925 and 26, you would think that would indicate that maybe something happened to the currents down below, and as we line it up and look, and lo and behold, we see the Atlantic had turned warm at that point, and one of the El Niñas occurred, and the Pacific had shot up into a warming trend. So right now, nature seems to agree fairly well with the theory. Now let's take that a little further. If we can expand these cycles, you might wonder, why am I looking to expand the cycle? Well, we're looking to buy equipment that's going to be around for 25 to maybe 50 years. I want to make certain over that time span that I have technology in place that's going to cover whatever circumstances we're challenged with. So again, here's the Pacific cycle, if it's repeatable, and we'll slide in the Atlantic. And then I'm going to look up above and match these up over here to see what might result from that. And when I do that, I find that it's indicating we may be heading back to the 1920s in temperatures. And if that's the case, that means that by around, that'd be about 2040 there, I'm still operating this equipment. If worst case we are in global cooling due to the ocean currents, then I could plan for my heating load a potential of a 3-degree drop. Now I want to convert this to temperatures for those who don't like smoking mirrors with degree days. So I've set up that same historic graph using Fahrenheit degrees. And what we see here, again, I moved the Atlantic out for less congestion on here. And if I move the corresponding temperatures, again, we're seeing, just as we did with the degree days, a potential of a 3-degree temperature drop. One other thing is we do have some more recent data to see if the trend has changed at all. We got January through March. So I decided, since I have historic information going back to 1893, I'm going to look at January through March of this year and see if there's any time period that was colder than that. And because right now, the 4,258 heating degree days you see here translates to a temperature that's under 18 degrees. And what we're learning is that's the first time it's occurred in 110 years. In fact, if I look January through March 1904, that was our lowest, which was 3,303 heating degree days, which correlates to, as you remember over here in the pictures, the 1904-1905 time period. And the 90-day temperatures average 17.32 degrees, and the ocean bays were freezing over. And then January through March 1919, 2277, 4,277 heating degree days. And that translates, as you see over here, 17.5 degrees for the January through March time period, which translates, as you can see here, to these images. And this is very reminiscent of what we were seeing in the last 3 months. If we look at the third coldest time period for January through March, we discover it is this year, January through March 2015. For the Lewiston Auburn area, it was 2,258 heating degree days. And again, if we were up around Bangor or the Allagash, it would have even been colder. This history is specifically for this region, all three numbers you see there. And at 2015, that translates to about 17.7 degrees. So, as I said up above, this is the first time in 110 years that the quarterly temperature around Lewiston, Auburn slipped under 18 degrees. So, is there collaboration with that? Confirmation? We see that here's a Bangor newspaper article saying it was the coldest in history for it, and it was somewhere around averaging 10 degrees through the first couple of months. We see throughout New England records broken. Midwest, Chicago, Cleveland, they were experiencing record cold temperatures. Um, Now, what was interesting was 2 years ago, I went to the National Climate Data Center to gather information because I was doing a presentation on this a couple of years ago and I was updating my charts. And they had a section for all Maine heating degree days. And they had it from 1895 to 2012. So I fed in the parameters necessary, and then this heating degree day chart was generated. This is year by year, my temperatures for all of Maine, while I was specifically looking at Lewiston, Auburn, which again, it's in a sweet spot. It should be slightly warmer than all of Maine. And this was pretty much confirmed by the data we see here. If I look at the National Climate Data Center, and they had on their chart that they were going to use an average based on 1901 through 2000, and that average was 7,854 heating degree days for that almost for essentially a 100-year period. And I saw their peaks over that period was 1904 and 1918, and I'm there. Okay, that's a good check. That's agreeing with the local raw data I had for Lewiston, Auburn. And so I've drawn their line here, the 7,854 for all of Maine over that time period. And then I looked at the Lewiston Auburn average, which was 7,511. As we would expect, it would be on average lower. We need less heating days than all of Maine, since we're in the sweet spot in towards southern Maine. So the main data, as I said here, appear to be reasonable with basic heating degree days I meticulously collected over time. So we've got some agreement here. Looks like a great website for future backup verification of heating degree days and cooling degree days in general for Maine. I thought back in 2013. And as I said here, again, the data makes sense because Lewiston, Auburn, and Saco interior region, we talked about this in one of the earlier parts, is the sweet spot of the warmest Maine weather experienced. So, with that data, I downloaded and archived it, and so I have it for future reference here, as you can see. And so, all in all, I would have given this information 2 years ago a B plus and A minus in the way of correlation with the raw data. Well, 2 years had passed. I needed to make this television presentation, and so I decided to go back to the National Climate Data Center and review their data 2 years hence. And again, here's the chart we had earlier, and I discovered that among other things, um, I went to the website to compare 2013, 2014, and pulled their data off, which you can see right here for heating degree days. And it struck me that this could be a concern uh, to the National Climate Data Center because uh, it looks like we're breaking a 100-year average. We're going above it, which could be the makings of a black swan. If you have global warming occurring, of course there'll be some aberrations where temperatures pop up and down, but this is kind of a warning sign that something could be happening. Because as I showed you before, if we look at the first 3 months of 2015, and if it's going to resemble, if it in any way resembles 1904 or 1918, at that point in time, this is a reversal, and that would truly be a black swan event because now not only have we had some spikes upward in recent years, but if we wanted to draw trend lines, we could see where uh, as heating degree days are decreasing, as you saw in the first part here, that would be global warming. We need less heating degree days. But in the last 20 or 30 years, now that trend is showing an upward trend. We're needing more heating degree days or experiencing more heating degree days, which would be a possibility of global cooling. So the question is, how is the Climate Center going to react to that? Well, they've published some information recently, and they pretty much said December 2014 through January 2015 was the sixth warmest in contiguous United States. Interesting. And I also saw an article by a professor at University of Maine who indicates in the next 35 years he's projecting a 3-degree increase in temperatures. Fascinating. So a Maine professor of the year states we're going to see a 3-degree warming over the next 35 years. That's a full swing 6 degrees from the data I have that is indicating the potential of a 3-degree drop. Do I go with the old timers on this furnace and go with a 6 ton? Or do I go with the United Nations and the professor and those who say that things are getting warmer? Now remember the chart that was seen earlier. It is incredibly important to know what's happening with heating degree days and temperature because that has a profound impact on the technology I'm going to put in and the size and magnitude of it. So I need to know, and this is just I'm converting the heating degree days from the prior chart to Fahrenheit temperatures here to show how dependent we are on temperature. So we need accurate information. And we're going to stop there on part 4 or 5, and part 5 will be comparing the 2015 data from National Climate Data Center to their data from 2013.